So rate equations. Now with this topic, just put up a specification. You need to know, define the term order reaction rate constant, perform calculations, explain the effect of change in temperatures under rate constant K, and then yeah, that's really it. And then obviously the other ones that use concentration time graphs, and the practical skills. So Arrhenius equation, you don't need to know this, but what you do need to know is why, as activation energy gets bigger, what happens to K? Well, K gets smaller because if you think about it, right, K equals AE to power minus ER, K equals AE to power minus E over RT. So if AE is getting bigger, EA is getting bigger, K equals AE to power, K equals AE to power minus, don't tell me I've forgotten the Arrhenius equation. Oh my days. K equals AE, yes, to power minus E over RT. So just by a mathematical perspective of increasing this exponential function as that tends to infinity, this whole thing is going to get smaller. K is going to get smaller. If we were talking about chemistry though, K gets smaller because the reaction has a high activation energy. And therefore not many reacting particles can react, therefore slow rate. But as temperature increases, K increases as temperature increases because more reactant particles react, reaction rate increases, and K equals AE to power minus E over RT. Arrhenius equation in logarithmic form, ln K equals ln A minus E over RT. Create Arrhenius plot by plotting ln K against 1 over T and gradient equals minus E over R. Order of a reaction, the sum of the powers to which the concentration of a reactant is raised to in the rate equation. And be very careful, that's order reaction. If it's asking you about the overall order, then you say the sum of the powers to which concentration reactants or reactants is raised to in the rate equation. Okay, initial rates method. Repeat experiment several times, use different initial concentration reactants, calculate initial rate of experiment, see how initial concentration affect initial rates, therefore work out order for each reactant, then we can work out the rate equation. Rate determinant step, the slowest step in a multi-step reaction. If reactants appear in the rate equation, they must affect the rate. So therefore this reactant or something derived from it must be in the rate determinant step. Rate constant K, a number that links the rate of reaction to concentration of reactants. And the bigger the value of K, faster the reaction. Well, rate constant K gets bigger as you increase temperature of reaction, because think about it. Increase the temperature, more particles will collide. Therefore, the activation energy, more particles collide, increase the number of collisions, concentration of reactants order always stays the same in this case. Therefore, K must increase as well. And therefore, K must increase because K must increase for rate equation to balance. Initial rate of reaction, the rate of reaction when time t equals 0. Yeah, find potentially calculating gradient at time equals 0. Again, yep, obviously initial rate of reaction is the rate of reaction at the start of the reaction. You should know that. Because initial rate of reaction. Continuous monitoring following reaction to the end by recording the amount of product you have at regular intervals and measure rate of reaction by continuous monitoring. Now this is a practical skill, so I'm going to get rid of it because the practicals I like to do separately. I don't like to include them in my flashcards.